Hello, hi everyone. So let's continue to chapter 4 part 3 digital modulation PCM. Alright, so recap back the PCM code step. We have sampling. First we need to sample the analog signal, and then we need to quantization to run off the sampling value, and then lastly is to code the signal to get the binary value. So here is step of PCM to convert, which is to convert from analog signal to digital signal, which is the binary value. So after we get the value of quantization, the middle value, we need to know the quantization error. So what is the quantization error? The quantization error, QE, is the difference between an input value, which is the original value, and its quantized value. So here is the equation. QE equals to quantized value minus original analog signal. Maximum magnitude QE is equal to 1/2 a quantum. So if we have the value of resolution, so QE is equal to resolution divided by 2. So here we need to know the quantization error. Alright. So the dynamic range, the ratio of largest possible magnitude to the smallest other than 0 magnitude that can be decoded by the digital to analog converter in the receiver. So here this is the equation of dynamic range. So here is the linear value. dr equals to Vmax divided by Vmin. Mmax minus Mmin divided by delta V, or is equal to 2 power of n, and in dB just 20 log Vmax minus Vmin, or 20 log 2 power of n. So here dr is the dynamic range in unitless. Okay, for this Vmin is the quantum value, Vmax the maximum voltage magnitude of the DACs, and n is the number of bits in PCM code exclude the sign bit. So example 2, consider an analog signal shown in this figure. Let's say we want to encode the signal using 3-bit PCM system. So first of all, we need to know our level. So we know that L equals to 2 the power of n. So now our level is 2 to the power of 3 is equal to 8 levels. So we need to divide this signal into 8 levels. Next step, we need to calculate the delta V, meaning that the step size for this signal. So we know that delta V is equals to M maximum minus M minimum divided by L. So what is this signal maximum value? So here is the maximum value, which is 6 minus the minimum value for this signal is -2 divided by 8 level. So the delta V for this signal is 1 volt. So each of this segment will divide it into the level. So -2 to -1 will indicate as level 0. -1 to 0 is belong to level 1 until the 6 volt. Alright. So, okay, until this equation, next we continue with the middle quantized value for level 0. So, we know that we have here, for that signal, we have from negative 2, negative 1 is level 0. Negative 1 to 0 is level 1. 0 to 1 is level 2. And up to level 8. So, for the first level, which is level 0, M min plus delta V divided by 2. So, for this level, M minimum is negative 2 plus delta V is 1 volt divided by 2. So, here is the quantized value or the middle value for this level, meaning that here is negative 1.5 volt. Okay, so go to the next level, which is level 1. So here is level 1. So level 1 we have M minimum is negative 1 plus delta V1 divided by 2, 0.5. So for level 1, the middle value is negative 0.5 volt. So try this one until level 8. So we can then build up a table, which is the PCM table or the reference table, to show the level and the corresponding voltage value. Okay, we need to build up the level, the quantized value, and the voltage range. So here is the solution for example 2. We have 0 until 7, which is 8 level, and the quantized value or the middle value is start with negative 1.5 volt until 5.5 volt, and the voltage range for the delta V is in between for the level 0, negative 2 to negative 1, which indicate that the delta V equals to 1. Same goes until level 7. So, last step is encoding. To determine the binary code for each PAM signal based on their level. So, let's look at the example 2 before, where we are trying to build a 3-bit PCM system. So, the lowest binary number should be 000, while the highest is 111. So we can then set the binary code for each level. So let's fill up this step. So here is level, quantized value, voltage range. So this is the code that represent the binary number of 3-bit sample system. So we start with level 0. So 000, level 1, 001 until level 7, 111. Okay, let's try exercise 3. Based on the PCM coding table here, for example 2, determine what is the quantized value and the PCM code for the following analog value. So, let's try A. For 2.35 volt analog value, it belongs to this level, okay, level 4. It is in between 2 to 3 volts, and then the quantized value is 2.5 volt, and then the code is 100. For negative 1.4 volt, it's belong to negative 2 to 1. So here is the level, here is the quantized value, and here is the binary code. So negative 1.4 volt, the quantized value is negative 1.5 volt, and the code is 000. Right. So for 5.78 volt, it belongs to level 7, and this is the quantized value, and this is the code. So 5.5 volt, and the code is 111. Okay, you guys try these two, negative 0.9 volt and 1.5 volt. So end of part 3, continue to part 4 after this. Thank you and stay tuned.